This is a standard Honda car engine. This is a standard Ford car engine. This is a standard Ferrari V8 car engine. What's one thing that all of these have in common? They're simple. Wrong. They're not very simple. They're extremely complex. They have thousands of different parts. Here's a video showing a very, very simple car engine. I do not mean that ironically. I mean that truthfully. You can see how already in this zoomed in schematic of just a section of a one-cylinder engine, considering we were looking at V6s and V8s before, that it's already extremely complex with lots of precision machined parts, random assembly. Many things can go wrong here, and it's very, very complex. Now we get to the gear train and the clutch. And you're rightfully confused, as am I, as is anyone that tries to grasp this entire engine themselves quickly. So what is the problem we're trying to get at here? The problem is that one person, a mechanic, has to know how to fix something that hundreds of people designed that took thousands of hours of R&D and university time and research and decades of development to make. How is that fair? How is that sustainable? New engines present ridiculous learning curves and increased repair time for these cars. Every time a new car is rolled out, every 2 to 3 years, it has a different tweaked engine and sometimes a completely new engine. And these are completely different than the ones they've worked with before. They have the same concepts, but there's still a lot of learning involved, a lot of time, and mistakes are made. These mistakes can cause improper repair and damage the car, decreasing the lifespan and hurting the trust in the automobile and the mechanic. So how can we really go about solving this problem? It seems something that's complex and just a side effect of the automobile industry, which it kind of is. One thing we could do is attempt to simplify engines. In order to do this, though, we'd have to get all these car manufacturers on board, and simplifying engines just really isn't an option because as it comes right now, they are getting simpler. They're becoming more simple, but it's still extremely complex, and it's not going to decrease to a level where it's acceptable for one person to manage this. The next thing is form-fit tools. These are used a lot in manufacturing to gauge if a product is defunct or not. These can be used for about 20% of repairs, making sure things are square, making sure things fit in a certain place, showing where screws should go, showing where different things should be, probes. But all of these are very complex. They're one use, so you'll have to have a ton of them just for one engine. They all have to be custom made. There's just a lot of logistics behind form-fit tools that don't make them suitable for versatile mechanic repair the way they are in manufacturing. The last solution, I think, is the best, and that's using augmented reality, something that's really not been utilized in the industrial space but has been talked about a lot. So when we talk about augmented reality, this is probably what you vision. Some goofy glasses and something that you can find easily already on your computer or on your mobile device. Something like this that Google or some other Facebook or some company has put out, and people like this, people you don't trust to make a good product, you don't trust to be in your best interest and be in the user's best interest. So I'm going to show you what I'm actually talking about when I say augmented reality in the industrial mechanics space.
Virtual user instructions and assembly instructions. AR-based virtual user manuals can display 3D holograms, overlays, and visual instructions in the form of 3D animations for products such as vehicles, refrigerators, cameras, and more. And when it comes to assembly instructions, we'll be able to see the construction of items such as desks, cabinets, and more in many phases in the form of 3D holograms and 3D animations. Thanks for watching.
So that's augmented reality, the way I envision it, and the way I envision to use it to solve this problem. But what's required to do that? Do we need some silly glasses? Do we need some super fancy sensor setup? The answer is no. All we need is a smartphone. And as it turns out, 80% of the world's population already owns smartphones. It doesn't require an iPhone, doesn't require a Samsung. It requires anything with a decent camera. And I'm not talking a camera like this. I'm talking about a simple camera like a $30 web camera. These 80% are also the most likely to also own an automobile and also be mechanics. So what's the required software involved? And this is where we really come in. We're not building iPhones, we're not building Samsung phones, but we will be building the software. First of all, we'll need a mobile app to display the augmented reality instructions and serve as the user interface. This isn't difficult. We're not inventing the mobile app. It's been used for a decade. There are plenty of augmented reality frameworks already on the market and already built in to Samsung's development environment, to Android's development environment, and especially Apple's development environment, making it super easy for us to build an AR app. We'll need somewhere to store the instructions and the data that we collect in order to display it to the users. This is very simple. Cloud storage solutions, any database, any backend as a service already exists. There are hundreds of different options. We do not have to invent a way to store this data. The last thing, which will be our biggest mark, is how do we create the 3D instructions? How do we create the interactive tutorials that the users will be experienced to? This is where CAD comes in. Companies like SolidWorks and Autodesk already have fantastic 3D computer-aided design programs. If we create a software extension for those programs that allow us to build off of the frameworks and all the 3D rendering they've already created, we can easily create a simple bootleg animation software that already uses their 3D models that the engine companies or that anyone that creates these models already uses. So in the end, who's really creating the instructions? Because this is where it seems like the most work goes in. Because once you create the mobile app, it already exists. Once you create the database, you only have to do that once. And then once you create the instruction software, you really only have to do that once as well. But you have to maintain an upkeep on making new engine instructions. I would argue that the engine company themselves are the ones responsible for this and the ones that would be best suited to do it. They already make pamphlets, detailed instructions, diagrams, many 3D models, many instructional videos. A ton of this groundwork for the instructions is already being done, researched, and shipped out to the end user, albeit in different forms. So I would argue that it would be extremely easy to convince a company to add this to the list of instructions that they provide. This could replace arguably everything else. So step one to mass adoption is building up the instruction catalog. If there are no instructions on the app, then you can't use it to build anything, and there's no reason to use it. So first of all, we have to get manufacturers on board. Those are the best people suited to make these instructions. What's in it for them, though? If we make cars more reliable, they sell more cars, or they sell less cars. A higher quality reputation is something they can't buy, and something this would easily provide. Also, once you convince at least one company, the others will flock right behind them, as the car companies have done this entire century. Everything from driving assistance to EcoBoost, and especially recently electric vehicles, have caused the car industry to move in a wave. Mass adoption step two. We have to get it in front of the mechanics, our end user, and in the end, the people that are going to be paying for this. So how do mechanics communicate? How do they get the information out to each other? They're not all in one giant Facebook group called mechanics. The biggest groups and the ones that are easiest to reach in a centralized fashion are already under legacy auto manufacturers. Once these legacy auto manufacturers are using it, because their companies will be sending out this information, then we can easily get independent mechanics to follow, as they see the leaders in mechanics being the legacy auto manufacturers. Mechanics have extremely detectable search patterns and a big print on the internet. We can market the app through Google Ads or any other ad service and easily narrow down our target to specific mechanic shops. One of the big cards under our sleeve would be partnering with vocational schools. If we license the app to one of these schools, once these students are using it, they'll want to use it when they're in the workforce, and therefore we start the cycle of the entire industry-wide learning how to be a mechanic through augmented reality. The big step three is monetization. Monetization will allow the company to expand into other instructional fields, not only doing engines, but doing other industrial equipment, 3D printers. Anything you can think of that requires maintenance, we will be able to expand into. If we monetize at 99 cents an instruction set, it creates great cash flow, and you're really going to have a hard time finding someone that won't pay $1 to save themselves a few hours and a headache. The big thing about this technology and its specific use case here is that it can act as a gateway for augmented reality. It's extremely practical and extremely easy to use. I think this use case could really demonstrate that augmented reality isn't some crazy technology that is just exists in sci-fi, and it's something that could really change how we see the world.